Okay, so here's the continuation of 2.8. Talk about using angles. First off, a theorem. That is a statement that can be proven true. Now we have things that we've learned about called postulates, and then there's things that we've learned about called theorems. And theorems are things that we can actually prove true. Okay, and so here's one of those theorems. This is called the vertical angles theorem, and this just says that all vertical angles are congruent. Now that's probably a little bit misleading, because really what we're saying when I say all is I'm saying all pairs. So maybe I should put that in there. All pairs of vertical angles are congruent. Because look here, we have some vertical angles here. And so this pair is congruent to each other, and this pair is congruent to each other, but they are not congruent this way or this way, right? It's just opposite of that intersection that they are congruent. So if that's true, we should be able to solve for x here. So let's go ahead and do that. I know that these two angles are congruent, so set it up and solve. 3x equals 4x minus 25. I'm going to just subtract 4x from both sides, which will give me a negative x equals negative 25. And then I'm just going to multiply both sides by negative 1. And I end up with x equals 25. That's a general rule in algebra too. I mean, you can always you call it multiplying by negative 1, but really, if everything's negative in your equation, you can just change the signs and make them both positive. If every single term is negative. So why don't you guys go ahead and try solving for y on your own. Find the values of y and the measures of the corresponding angle. Oh, I forgot to find the measure of this angle. If x is 25, what does the measure of this angle have to be? Well, it would be 3 times 25, which is 75 degrees. And that would mean that this one down here is 75 degrees as well. Alright, so go ahead and see if you can find y. Pause the video, and then I will put the answer up. Okay, here you go. You should have got that y equals 15, and that angle over here is 105. If you were to plug in 15 for 7y, you'd get 105, and if you plug in 15 for 5y plus 30, you'd get 105. Now the interesting thing here is you could have found this angle measure without even setting these things equal to each other, because you have a straight line right here, and so these two angles have to add up to 180. 75 plus whatever this is has to be 180, so you could have said 180 minus 75 to find this angle, which is 105. So there's more than one way to find it, but we did it by using vertical angles, and that's just fine. Okay, I think we are, yeah, let's talk about this real quick. No, diagrams are deceiving. Do not trust your eyes, trust the math. This is something I say in class every once in a while. You're going to see things, hopefully not too bad, but you might see something like this. And then you might see it say that. Well, that is the symbol for a right angle, but that sure does not look like a right angle, right? Well, the general rule in geometry is trust what the markings say, or trust what the information says, not what the drawing looks like. So even though this doesn't look like a right angle, if the drawing says it is a right angle, then it is. So, you need to treat it with the information given, not what it looks like. In fact, look up here. This says that it's 75 degrees, but that looks like it's not 75. It looks more than 90. So, and this one looks less than 90, but the information tells us otherwise. And so we need to trust the information, not the drawing. Okay, let's go on to the next page. Okay. Theorem 2.2, congruent supplement theorem. If two angles are supplementary, so I'm going to just write sup, of the same angle or of congruent angles, then the two angles are congruent. And so kind of explaining what that means, they're saying, hey, if 1 and 2 are supplementary, they make a straight line, and 3 and 2 are supplementary, they make a straight line. That means that 1 and 3 have to be congruent to each other. Now, let me show you what that looks like with the math. I'm going to go over here a little bit. And let's say I was to say, hey, angle 1 plus angle 2 equals 180, right? And let's do blue over here. And let's say I was to say, hey, angle 3 plus angle 2 equals 180. Well, let's solve for the individual angles. So I'm going to solve for angle 1 and solve for angle 3. So I would do that by subtracting on this top one, subtracting angle 2 from both sides, and I end up with, hey, angle 1 equals 180 minus angle 2. And now let's solve for angle 3. Subtract angle 2 from both sides, and you get that angle 3 equals 180 minus angle 2. Well, look, these values are exactly the same, 180 minus angle 2, 180 minus angle 2, so we know that 1 and 3 have to be congruent. And that's basically what this theorem is saying. If two angles are supplementary to the same angle, then the two angles are congruent. And a very similar theorem is the congruent complements theorem. It's the same idea, but now we're talking about complementary angles, so angles that add up to 90. So if two angles are complements, I'm just going to write comp because I can't really fit it in there, of the same angle or of congruent angles, then the two angles are congruent. So same idea, you got 1 and 2 equal 90, 3 and 2 equal 90, subtract angle 2 from both of those and you would get the same value. And here notice they keep saying the measurement of angle 1, measuring angle 3, that's what that little m means. Therefore, that's what those 3 dots means, angle 1 is congruent to angle 3. Alright, angle 1 congruent to angle 3. That's what they're trying to show you there, is that we use the measurement symbol when we're talking about equality, and we don't use the measurement symbol when we're talking about congruence. Alright, another theorem, this is really simple. They're just saying, hey, all right angles are congruent. And that makes sense, right? Because all right angles are 90 degrees, therefore they all have the same measure, therefore they are all congruent. Alright. Theorem 2.5 says if two angles are supplementary and congruent, so they add up to 180, supplementary, and they equal each other, then each angle has to be a right angle. Each angle is a right angle. So here I got two angles that add up to 90. Therefore, I have two angles that add up to 180, straight line, and they are congruent. Therefore, they must both be 90 degrees. Okay. That's the end of these notes. So, yeah. You can try and write the summary if you guys want. Describe how you can use vertical angles theorem to find the measure of all the angles formed by two intersecting lines. So basically what I'm asking there is, hey, let's say I had some vertical angles. Call them 1, 2, 3, 4. And I was to say, hey, angle 1 equals 30 degrees. Could you find all the rest of these angles? And you could, but I want you to describe how you could. And that'll help you. Okay. Adios.